This video is piggybacking on the previous video I did on muscle terminology as it applies to skeletal muscle physiology. And one thing we had talked about is we talked about the contractile filaments, thick and thin filaments composed of myosin and actin molecules respectively. Here we have in purple the thick filament, green's the thin filaments, and we also spoke of the regulatory proteins. In blue here we have tropomyosin, in yellow we have troponin. Keep in mind troponin is the binding site for calcium, and troponin does not look as I've depicted it here. Troponin actually has 3 different subunits to it, but I'm just simplifying this dramatically. This is troponin, which is the binding site of calcium. One thing we outlined in the previous video is that calcium is stored in the sarcoplasmic reticulum of muscle fibers, and to allow for muscle contraction, the calcium needs to be released from the sarcoplasmic reticulum. We'll cover how that is released in the next video, but one thing I want to show you here is what happens when calcium is released. So the space between these adjacent thin filaments right here is known as the H zone. We see that on the top and the bottom. That is the H zone, from here to here and from here to here. When calcium binds to troponin, it causes a conformational change in troponin, and that's why I've demonstrated it going from a circle like this, calcium bound to it, it's a nice flat protein. And when troponin undergoes that conformational change, it actually moves tropomyosin up and out of the way. If we look right here, the myosin heads cannot bind to the thin filament because tropomyosin is blocking the binding site on the thin filament, both at the top and at the bottom right here. But when calcium binds to troponin, troponin undergoes the conformational change, moves tropomyosin out of the way, then that liberates the binding site, and these myosin heads all grab the thin filament. And then what happens is the myosin heads fire and they slide those thin filaments closer to each other. Now, what I've shown here, troponin has more of a block structure than this flattened structure. There would be no conformational change here. I just didn't have space to have that elongated rectangle in this space right here. My point being is here is the sliding of the filaments, which allows for muscle contraction. So we see here the H zone is dramatically diminished in width than we saw right here. So we saw that this is the sliding of the filament. I haven't shown the sliding of the filaments in this video. I just wanted to outline the importance of calcium, which is to cause that conformational change in troponin, move tropomyosin up and out of the way of the binding site to allow the myosin heads to grab the thin filament, pull those adjacent thin filaments closer to each other, diminishing the H zone, which is shortening of the muscle or muscle contraction.